Today, we're reviewing a continuation of Differential Equations, Chapter 1.1, Definition and Terminology. We are going to understand what an explicit and implicit solution is existing on an interval for a ordinary differential equation. So let's look at our first example. Here we're going to see if this equation is a solution to the second derivative of y minus 2, the first derivative of y plus y equals 0. So we start by taking the first derivative of y, then proceed to taking the second derivative. As you can see here, it's important to remember that when deriving multiplication, it's the first term multiplied by the derivative of the second plus the second term multiplied by the derivative of the first. Now we're going to proceed to substituting our value obtained for the second derivative in the first term. Then we're going to substitute the value obtained for the first derivative in the second term. And lastly, we're going to substitute the value of y into the third term to see if all of this satisfies the condition of the equation. We are left with this. Now, canceling like terms, 2e to the x goes with negative 2e to the x, and negative 2x e to the x cancels with the sum of x e to the x plus x e to the x, which we're left with 0 equals 0. So yes, y equals x e to the x is in fact a solution. Now for our next example, we're going to see if y function of x equals sine of x minus cosine of x plus 1 in the interval of negative infinity to infinity is a possible solution for the second derivative of y plus y equals 1. So we're going to start by taking the first derivative of the equation, then proceed to taking the second derivative. Here we just have to remember that the derivative of sine is cosine and the derivative of cosine is negative sine. Taking the value obtained for the second derivative of y, we're just going to substitute it into the first term of the equation. Now we proceed to taking y and substituting it in the second term of the equation. Canceling negative sine and positive cosine with negative cosine, we are just left with 1 equals 1, which means yes, y equals sine x minus cosine x plus 1 is in fact a solution for this equation. The solution interval for a differential equation can be understood with this simple example. So y equals 1 over x, and the domain of 1 over x is from negative infinity to 0 and 0 to positive infinity. This function is not defined at 0, which means 0 is not a solution for this equation. Taking the derivative of y, we have negative 1 over x to the 2, which in other terms is the same thing as negative 1 over x elevated to the 2. And as we can see, 1 over x is the same thing as y, so we can rewrite this as negative y to the 2, which means y is a solution to this derivative. But we have to take into consideration that is not a solution for this derivative at all points. It's only a solution from 0 to infinity and from negative infinity to 0. All of the cases we have seen have been explicit solutions for an ordinary differential equation. So now let's see what an implicit solution is. So by definition, an implicit solution of an ordinary differential equation on interval I, provided that there exists at least one function that satisfies the relation. So at least somewhere in that function it satisfies the differential equation, not necessarily on all points. So let's look at this example. X to the 2 plus y to the 2 equals 25. Is this an implicit solution for negative x over y? So we start by taking the derivative with respect to x of the equation x to the 2 plus y to the 2 equals 25. Solving this equation for the simple dy dx results in negative x over y. But when we solve x to the 2 plus y to the 2 equals 25 for the y in terms of x, it yields y equals positive negative square root of 25 minus x to the 2. Both functions satisfy the relation of x to the 2 plus y to the 2 equals 25, which means they are explicit solutions defined on the interval negative 5 to 5. And x to the 2 plus y to the 2 equals 25 is an implicit solution. To further understand implicit solutions, here is one last example. So we have x plus y plus e elevated to the xy equals 0. Is this a possible solution for the following equation? So we start by taking the derivative with respect to x of all the terms. And here what's important to remember is when taking the derivative with respect to x of e elevated to the xy, y is a function of x. So here we apply the chain rule. It would be e elevated to the xy multiplied by, and then we apply the multiplication of derivatives rule, which is the first term multiplied by the derivative of the second, and the second term multiplied by the derivative of the first. Then we do multiplication, distribution, and we regroup the derivative of y with respect to x. And rearranging the terms, we are left with 1 plus x elevated to the x times y multiplied by the derivative of y with respect to x plus 1 plus y elevated to the x times y equals 0. So yes, this is a solution, but not everywhere. So if we do the vertical line test to test if this is a function, we see that x plus y plus e to the x times y equals 0 is not a function, for it hits two different variables in the vertical line test. It does not pass. So being this is not a function, it can't be a explicit solution for this equation, which means it's an implicit solution. It implies that inside of that function there is somewhere where it is a solution, but not everywhere. So thank you for watching. Good luck, guys.